Today, I'm going to show you the Coder Dojo Kingston University robot fleet, which I built with my co-mentor Mike. I'm going to tear one down and then rebuild it step by step, fixing some problems on the way. I'll talk about some of the design and show some minor fixes on some of the fleet. Let's get into it. The Coder Dojo fleet has 11 robots, my initial prototype, and 10 more for the dojo. At the Coder Dojo robotics activity, kids program these robots with MicroPython, playing with I/O pins, LEDs, buttons, motors, then sensors and robot algorithms. One design decision made early with these robots was to use M3 bolts for nearly everything. There are some M2.5s where the corners of the board connect. So this poor puppy has suffered a little bit and has got a sheared off standoff right here. So I'm going to take out my trusty tiny toolkit and I'm going to go to the screwing unscrewing page. These shields were an idea that Mike proposed. They've been designed in FreeCAD and the STLs are going to be available. And they're really here to tidy up the wiring and also protect the motor and battery wiring because of the potential of short-circuiting batteries or putting motor wires where they shouldn't be. Plus it also makes these a little bit easier to transport and carry when they have a bit of protection. So take off those, they're just M3s. So inside here you have motor connections. We've also crimped on for the LiPo a JST connector that matches this one, so it keeps it nice and polarized so you can't really get it wrong. Unscrew this side, which is the plate. And now you can see the sheared off section. Let's get this other one off. A nut and a standoff with a threaded end. The other one, the nut has gone. You see that thread has snapped clean off. So we're going to need to replace that one. Let's unbolt it anyway. Before I get any further, I'm going to unplug the lithium ion. So that's now safe. Unbolt these. Unclip these. Take that out. I logically made them go to the two ultrasonic distance sensors. Now these look like HCS-R04s. They are the RWCL 1601s, compatible with the HCS-R04s in terms of how they operate. However, they are guaranteed to be 3-volt compatible, and being based on an RP2040, this needs to be 3-volt. The MakerPi 2040 from Cytron, it's got a speaker, 2 RGB LEDs, a bank of on-off LEDs, I guess. It's got 2 motor drivers, and when it's powered on, you can use these buttons to test the motors, which is quite handy for kids getting to know how to drive motors. It's got a USB input, so micro USB, which you can use both to charge and to program. On-off for supplying battery power. A couple of user buttons, a reset button and a boot button in case I want to reflash the RP2040. It's also got a bank of servo connectors, which we're yet to make use of in the dojo. We want to find a good way for kids to get excited about maybe playing with some simple servo motors. Maybe I've got some ideas for that. We'll get into that some other point. So it's a very handy board, and these connectors make it so you can't really reverse bias and start shorting things or so on. They're all behind the shield, but if you pop them into another one, you'd have to change your code and change which pins things are on. But generally, it will all still work. So we've made that relatively easy to maintain in that respect. But it's 3 volts, so we have to have 3 volt ultrasonic distance sensors, which meant I also needed a custom plate because these actually have different dimensions from the HCS-R04, and I've not been able to find brackets and plates, so I just designed one in FreeCAD and 3D printed it. Right, let's get this layer up. Oh, I need to unscrew these first. Let's take the motors out. At least the motor connectors. And that will set this board free. Here we are. Okay, now this layer's all the electrical connections are out of it. And we'll take this off. So these are the only M2.5s in the build. I've tried to standardize on M3, but again, this board had M2.5. There are these larger, wider, which I don't really think you could use for anything. I mean, they're too big for M3. These might accept an M3, but they might also be M2. But the solution I went with was to go with the four corner bolts. Here we go. That's the board free. You can have a look at the back of it. Belongs to, so you could stick a belongs to. Now what I could do is say belongs to 0, my very terribly written 0. So it might be a nice idea to write down which one they belong to. They've got pretty good labels on all of the items. So everything says a GPIO number, even these RGB LEDs and the speaker. They've got pinouts for all the other pins, the Grove connectors, the debug connector, but it's just handy to have that as a reference. I really like this board, and I think Cytron has done a really great job with this. So under this, actually we do have more M2.5s. These could have been M3s, but there we are. And so they float this way, and I had to put these kind of ears in to allow it to wrap around where the posts were. So again, all designed in FreeCAD and 3D printed. Same for the other side. There we are. I'll keep those together. I am keeping different phases of parts together. It's not quite a tidy knolled mise en place. It's more like groupings that I can put together quickly when I come back. Okay, the next part we're going to need to remove from this is going to be the wheels, which are held in by screws into the nylon shafts. Now, one flaw with this is I'm slightly worried that the screws bite into the nylon shafts. They might end up worn, loose, cross-threaded. So I'm a bit concerned about how many times I can unscrew and screw them without it becoming a problem. But they are relatively easy to take off. Okay, and now I'm going to come in from the bottom. And we're going to take off the line sensor. So we got 3 connections there. There is a 4th connection because all Grove connectors come with 4. It doesn't really do anything. Maybe I need to tuck it inside just so, because I've had at least one mentor go, oh, spare wire, maybe I need to plug it in somewhere. And if you do that, the line sensor misbehaves. I think they plugged it in next to all the other 4 and it went into calibration mode, which was very confusing for everybody. Take those off. So the line sensor is also Cytron. It is the Cytron Maker line. And this gives you either individual outputs for each of the sensors, and these are optical line sensors, or it gives you an analog output. And the analog output kind of reads based on an algorithm here that decides where the line is in relation to the sensors, which is going to be far easier for kids to read the analog output with an analog input pin on the MakerPi 2040. It actually will face this way down when mounted on the robot. It's got a set of LEDs here, so if it's sensing a line, the LEDs will light up. There is a calibrate button, which calibrates and stores settings, so you can calibrate based upon your light or reflectivity conditions. That's kind of handy. There's a belongs to again, so I could put the robot number on there again. There's a power light. There's also a light dark switch, so you can switch which mode it's in, whether it's sensing a dark line on a bright background or a bright line on a dark background. All in all, it's quite a handy little device actually, and it's been very reliable. Pair this with, you can do a simple bang bang or a PID algorithm, and you can get quite smooth line following. This one, I'm going to need a spanner from the rear as well, I think. So I'm going to need support underneath here, and this one here. Once it's loosened, which hopefully you can do without throwing the spanner on the floor like I did, you can just pop that off. generally easy to use your fingers once it's loose, right? Yeah, okay, that's the maker line off. So we're going to need to start pulling apart the chassis layers, the sandwich. And that's a good idea on this because this one also, the battery is loose, which is generally a very bad thing. We can get in and see more of it. So I'm going to get in there. I'm supporting just this metal support with my hand. They're generally, again, finger tight, but if they were not, I would have to use either the flat blade pliers or a spanner to support them. But they're coming fairly nicely apart. And you'll notice those are definitely M3 bolts, but this is an original that came with the robot. Should probably go and check the Adafruit sheet on what hardware it has again and refresh myself. So now we run into where I've disassembled it slightly out of order because that cable is threaded through each plate through this slot, and that goes all the way to the bottom. So before I'm able to pull those plates apart, I am going to need to slide that through. That means I'm going to need to push these pin headers, female pin headers, through there, and it's putting up a bit of a fight, and then push them through here because those Grove connectors won't go through the other way. There we are, and that's now separated, and I can pull that through. Okay, so we have one plate loose, and I'm going to keep that plate with those parts over there. One of these supports came off completely. I wonder if that was already missing a bolt, because I've got 3 screws and 1 support, and that support should have been bolted in from somewhere under here, so I'm probably missing a bolt. Okay, so there's my Grove cable. I can keep that over with the board. And as we disassemble it, we're going to find that we need more space to keep the components. Okay, so these are bolted on with these tiny screws here. And again, I've broken my own rules because those are M2.5, not M3. And again, I'm sort of supporting the nut underneath, but if it was getting tricky to support, I should use the pliers instead for that. So I need to unbolt them before I can unclip them. And this one, I think that shield is actually also slightly cracked. So this one, sheared bolt, cracked shield. It had a loose motor when it arrived as well, which I tightened up on the day. I think it got dropped. I expect in a busy dojo occasionally accidents will happen with these. So there's a little bit of cracking on the shield there. It'll hold. It's not so damaged I need to reprint one. I do have the STL, so maybe later I will. Okay, and these just slide out. They're only really a friction fit around the cans. It took a certain amount of trial and error to get my printer to print these so around these lengths and this area here, to get them to print them just right. But the concept being is it allows the cans to push through. It's got a slot for the other end of the pin headers, the soldered connections just there, and then it bolts onto the body in a particular way to keep them at an exact angle. So kind of handy. In some ways this is better designed than where this is just bolted on and I kind of just line it up and eyeball it. This one will keep them at a specific location. With the 2 bolts here and the middle column, it's always going to be aligned with the center. Now, I'm not going to unplug the wiring here. There's a documented maintenance guide that says basically what colors need to go into what pins, so we can make sure they don't end up wired in incorrectly. Let's put those aside and get into the next layer. So the battery, we're not quite ready to take that off. I'm going to leave that attached to this layer for now, but I am going to move the motor wires far from the battery as I can now that I've freed it all. And now we can start getting these layers apart. So that, I can't really get to that bolt, and there's a bolt holding those in. They're not standoffs with an extra thread on the end, they're standoffs with this double side. I actually prefer, if I can, to work with these, because I can stack them right through. I don't know, I tend to prefer those, whether they're in nylon or brass, than the ones that have 2 threads on each side. But that is what came with the 3-layer mini round robot chassis, so I'll go with it. So I think we'll need to unbolt these to loosen the motor, and then we can get to those, and we can get to what's behind the caster. Let's see. So these unscrew fairly easily. The screwdriver I'm using is an iFixit. Right, that should slide off. There we go. So these are held by 2 slots here and here, and these tabs engage with the 2 slots to keep the motor stable, and then the plate compression holds the motors in place with these 2 tabs. But now I've taken off the bottom plate, the motors pretty much slide out. Let's just have a closer look. So these are the plastic gear TT motors. They're not expensive, they don't have encoders, they're just simple DC gear motors. There's a little gearbox, likely to be all nylon plastic gears. And then this little plate here is what engages those slots. Got long screws just straight through to hold those plates to the motors. Yeah. And we're going to have one of those per motor. Okay, motors are free. I'm definitely running to some space issues. I'm going to put the toolbox further aside here. So let's just get these extra posts off. I've done that. So there's 6 posts. I've done a tripod arrangement on each layer. Because they don't have the through screw holes, I've had to do 1, 2, 3, and then 1, 2, 3, and then it's a matter of making sure all the sensor mounts and things don't get stuck on them. Hence the little ear parts here and the cutout to slot around one of these on the front as well. So had to think about that when designing the sensor mounts. That one's already very loose, so I can easily take that off with my hand. I suspect these 2, oh no, they're loose as well. Okay. Right, and now we have the caster. I'm going to need this. Once it's loose, I can do it with my hand, I guess. And got 2 fixed holes here which fit nicely. So I didn't want to go with the sliding holes because these slide and those slides would be all over the place, but those 2 fixed holes and sliding slots here line up nicely. So caster is out. Okay, we've got another plate, so 2 plates. These plates do have space for encoders. It is possible we could bring encoders into the Coder Dojo, but number of children who get to take place in the activity, we've got limited spaces. We kind of thought, well, we keep to a more limited set of sensors, but the option's always open to bring encoders into play, and maybe we'd go and buy a set and use them on each robot. Right, the battery. Now, so this is an 18650. It's a lithium-ion battery. It's almost like an AA. It's just much trickier to get out. These are normally, fairly frustrating to remove from their cavity, and that's partially because you basically don't change them. Unless they really go, you're mostly just going to recharge them. I'm also loath to use anything but a plastic tool, and the one reason is because if I want to tighten up this bolt here, the other end of that bolt is a countersunk bolt under the battery, so I have to get the battery out to get to it. Okay, with much wrangling, I have the battery out. And this countersunk nut was basically because I had them in my lab. You'll notice it is using a hex head. So that needs a hex tool to get to it. If I get the right size. Yeah, there we are. So I can engage that and take that off. And then we can survey the parts and put it back together. So the robot centers around this Adafruit 3-layer mini round kit with hardware to attach it all. It comes with the wheels, the caster, the motor clips, and these two motors. We then add batteries, the Cytron MakerPi RP2040, pair of distance sensors, the Cytron Maker line, and the 3D printed hardware to mount all of that nicely and give it a bit of style and protection. If you have kids in the Richmond or Kingston or Teddington or nearby area, look up the Coder Dojo Kingston University and they might be able to come and play with my robots, or build a game in Python, or just get started in programming with Scratch. Maybe I'll see you there. Please leave a like or subscribe and comment if you've got any questions or ideas. And that's the disassembly complete. So in part 2, we'll look at how we reassemble this robot. And maybe we can get into more of the story about how it was designed. I hope you've enjoyed this video. Go make stuff and be awesome. Bye.